Hi, everybody. Welcome back. So as everyone kind of trickles in, I wanted to take the opportunity to introduce our next speaker, Mollie Enright, who is a current PhD candidate at the University of Toledo, who's also another green chemistry commitment signer. And Mollie has actually done a lot of work with Beyond Benign in the past and also currently as our graduate student liaison. And so I will stop sharing my screen and I'll hand it off to Mollie to talk about all the work she's been doing.
Okay, I think, do I need to wait another minute or are we good to go?
Let's go for it.
Okay, awesome. So again, my name is Mollie Enright. I am a fourth year PhD student at the University of Toledo, and I also am Beyond Benign's graduate student liaison in my spare time in grad school. So let me pull up the laser pointer in case I need it, and let's get going. So I'm going to be sharing my essentially green chemistry journey. And that started at Gordon College as an undergraduate starting in 2011 and into Beyond Benign as a program manager for 3 years and now here at the University of Toledo. And this is me when I'm not looking like a grad student. And what I want to really illustrate is that green chemistry has been the thread that has been kind of tying all of my professional and academic experiences together pretty much right since the beginning. And it's really shaped pretty much the full journey up into professional career and research that I'm doing now and what I'm looking to do after graduation. And so my first exposure to green chemistry was at Gordon College. That is a small private liberal arts college on the North Shore of Boston in Massachusetts. And my first exposure was in the general chemistry course. So a little bit of discussion in lab, a little bit of discussion in lecture, but really where I got my first kind of bigger picture exposure was through the student chapter of the ACS at Gordon. And our chapter was super, super active. We did a lot of outreach events, and there was also a lot of professional development happening within the chapter, bringing people in for lectures. And green chemistry was really the foundation of everything that we were doing. If we were going to do an activity, the question would be, okay, well, how can we make this a green chemistry activity? So learned a lot there informally. And then moving into the organic chemistry course, this is where I started to get much more of a formal background in green chemistry. So if any of you know Irv Levy, he was my organic professor, both for lecture and for lab. And he did a really excellent job of weaving green chemistry in through the lecture and showcasing, here is a traditional reaction that's in the textbook, and here's why nobody does this anymore from a green chemistry perspective. And similar types of things in lab, we were just discussing in a breakout session, one of the green chemistry alternative labs that we did in place of a traditional lab, which was, I think, the dehydration of cyclohexane. You can correct me in the chat, please do if I'm wrong. And as a part of this course, we were all required as students to perform or to participate in the Green Organic Literacy Forum project. So it's kind of a mouthful. And if you want to learn more about what this project is, there's a citation up here in the corner to an ACS symposium series book chapter that discusses all of these projects at Gordon up until 2009. And you can learn a lot more about what students had done. But my particular project, which all of the projects covered 2 semesters, was to work with my former 8th grade science teacher at her current school. And me and 3 other students led a 1-hour hands-on middle school level intro to green chemistry workshop that had a lot of hands-on components and utilized a number of different activities and experiments. And that was my first kind of big launch into green chemistry outreach. And it was incredibly fun. But then organic chemistry ends and I move into my upper level courses and I begin doing an undergraduate research project that focused on this pigment here. This is lycopene. It's the primary pigment in tomato fruit. It's a member of the carotenoid family. And the project started off with an interest in plant science and the relationship between the amount of pigment produced by the tomato based on its growth environment, and then looking at the analysis that is just presented in the literature as standard. This turned into a green chemistry project of, okay, how can we actually make the quantitative analysis and quantitative extraction of this pigment in a much more environmentally friendly and human health friendly fashion. And so this project went on for 3 out of the next 4 semesters of my undergraduate career, -1 for study abroad. And that turned into a honors thesis, which I was able to present at the American Chemical Society in Denver. And then if we just kind of fast forward through a lot of other things that happened in undergrad, that brings me to graduation. And the summer after graduation was my first exposure into the greater green chemistry community outside of just the Gordon bubble, as we would call it. And I was awarded by the National Science Foundation one of their scholarships for travel to the Green Chemistry and Engineering Conference and to participate in the student workshop. So here's me. These are pictures from the ACS Green Chemistry and Engineering Conference website. And just getting to sit at the table with current graduate students and postdocs and realizing that my undergraduate education at Gordon prepared me in green chemistry to a much higher level than the average student. And being able to see why that was, where the gaps are for the average student, was a really interesting and important perspective to get. And I was able to present my research there, have some great conversation with faculty, and just make some really amazing contacts. Like this is me talking to Laura Hoke who's now at Patagonia, if any of you know her. And I'm sure that there's other students here that you may recognize just from the green chemistry community now. And after that is really where I began working professionally within the green chemistry context. So I served as the program manager for Beyond Benign for 3 years. And at that point, I was the only program manager, which meant that I wore almost every hat possible for a program manager at a small science education nonprofit. And what that meant was a lot of face time with teachers doing teacher training. I got to work with teachers doing curriculum development, testing out new activities, helping to write new activities, brainstorm new activities. We were co-located with the Warner Babcock Institute for Green Chemistry at the time. And so at that point, we were running field trips and hosting tours. So I was able to interface a lot with students and be able to showcase current research that's going on in green chemistry while also providing them opportunities to do their own hands-on activities. I would go to conferences and host booths at our expos for either for outreach or for our curriculum focus side to work with teachers. So all sorts of things happening in my life as a member of the Beyond Benign staff. And one of the primary components of my job at the time was green chemistry outreach. So I managed almost all of the green chemistry outreach work that we did. And what that looked like was, it was very different day to day and very broad, but I was able to work with a lot of students and train a lot of undergraduates in how to do green chemistry outreach. So we were running at the time the Beyond Benign Outreach Fellows Program, which worked with, we had about 30 to 50 undergrads from local undergraduate institutions in the area who would agree to work with us for a year as green chemistry ambassadors for public learning. And I would, alongside Beyond Benign staff, we would train them in basic principles of green chemistry, basic principles of doing community engagement activities, and work with them throughout the year to manage community partnerships and make sure they had all the materials that they needed, answer any questions. And in many cases, I did outreach alongside them at bigger events. I also was able to develop 2 brand new activities for Beyond Benign's library and test them with students and test them with teachers. And then in some really fun opportunities, I was able to go back to the Green Chemistry and Engineering Conference, and with Beyond Benign, working with the American Chemical Society Green Chemistry Institute to take the experiences that I had as a student participant and what I gained from working with my fellow participants and postdocs and grad students and undergrads, and see what it was that students were looking for from the conference, and help them to both design and facilitate 2 workshops while I was program manager. So as a fun full circle thing. And 2018 was when I transitioned into the University of Toledo as a graduate student with the aim of pursuing a PhD. And so Toledo, if you're unfamiliar with us, we are in Northwest Ohio. We're a mid-level research university with about 75 grad students, 20 research faculty. One of the big draws was we have a really strong instrumentation center and really good NMR facilities. And the primary draw for me was the School of Green Chemistry and Engineering, and that was how I was connected to University of Toledo, was recommendations from my boss, Amy Cannon and John Warner, and suggesting that this be a place that I consider. And so that is what I did. I was accepted, joined the university in fall 2018, and in spring 2019, I guess, January 2019, I joined Mark Mason's research group. This is Mark. He is the director of the School for Green Chemistry and Engineering, and he also teaches the green chemistry course at Toledo, which covers a very broad range of green chemistry concepts that is open to both chemistry and engineering students at the undergraduate and graduate level. So there's a lot of students that take that class. It's been really, really useful. So Toledo really has been working to incorporate green chemistry in a lot of different ways at both undergrad and grad level, which is why I wanted to be here and why I wanted to work with Mark. So he took me on with the assumption that we would be developing our own green chemistry project, that we didn't know what it would be when I joined, and we would look for common ground in our interests and choose something together. So that's what we did. And the manuscript's in preparation. It should be out hopefully before the Green Chemistry and Engineering Conference this year. And the first paper was focused on the Suzuki type coupling using heteroaryl boronic acids and pyrrole and pyridines to synthesize these hetero or biheteroaryl compounds that are really important in medicinal chemistry and of interest to our group as ligands in main group chemistry and catalysis, catalyzed by iron in place of a traditional Suzuki type coupling using palladium. So if you're interested in that, we can absolutely talk more about it. But my focus here is going to continue to be the education side of it. So feel free to reach out to me in the chat if you want to talk more. But for this research, we were awarded a 2019 Acs Ignition Grant, followed by I received the 2020 SIBA Travel Award for this, which, so I'll be back at the Green Chemistry and Engineering Conference in June with an update on this work. And as a graduate student, for me, I think I would probably feel a little stuck if I only could just focus on research. So I wanted to make sure that whatever lab I joined, my professor was going to be supportive of the work that I did in an extracurricular sense for the green chemistry education community. And Dr. Mason has been super supportive. As long as I get my research done, he lets me kind of play in the education field as much as I want. And so right off the bat, my first year as a graduate student, I was asked to host a remote teacher workshop as a part of the Central Region ACS meeting at the time. And so we hosted teachers as well as University of Toledo faculty to go through some hands-on beyond benign experiments focused on green chemistry innovation. So that was really, really exciting to have the department chair support and be able to use our own facilities here and to work with university faculty and to talk with them about what's happening in the labs for both majors and non-majors, and what type of outreach we're doing as a university and as a department. And so moving into my second year, I was asked to host or to coordinate and collect volunteers and plan our department's outreach table at a local STEM event at one of our neighboring universities, Bowling Green State University, just about a little southeast of us in Northwest Ohio. And so that's what we did. We had multiple activities and we had multiple volunteers. These are two of the students I came in with as a grad student in my class. one of which has a master's, the other is currently still on the PhD track with me. And now as a graduate student, I am no longer teaching chemistry labs. At this point, I am the graduate assistant in the instrumentation center, which is separate from the chemistry department, but works really closely with it. And the instrumentation center runs their own outreach program that utilizes remote access to their instruments for high school, middle school, and community college classrooms. And so with that, I've been able to kind of sprinkle in some green chemistry as we go. And we host student tours, and I've been able to do some of the Beyond Benign outreach activities with students who are coming to campus, and then tie it in to the work that we're doing through the SCOPE program here. I think that my viewer is locked, but I can see the SCOPE logo is behind the chat windows. And so being able to tie those two pieces together so we can talk about biomimicry and sustainability and look at some innovations on paper, and then they go and look at either a butterfly wing or a gecko skin that we just talked about on paper, and now they're looking at it under the scanning electron microscope. So that has been really, really fun for me. And next week I'll be going with them to a high school to be doing this biomimicry matching game activity with, I think we have like 60 or 70 high school girls that I'll be able to work with. And that was all under the hats or under the umbrella of my life as a grad student. And so my other professional life is this role as Beyond Benign Graduate Student Liaison. And that is just a constantly shifting, constantly changing role. And I think that's what makes it so fun, is being able to just see what green chemistry education stuff can we do, where can I fit well, where do my skills fit, and where is there a need. And so one of these needs that I saw really early on, before I even left Beyond Benign, is that student ACS chapters really, really want that green chemistry award. And many of them don't know how to get it. And they try and they apply for the award. They don't get it, and then they're frustrated because they don't know why they didn't get it. And I'm sure many of you have seen this, that there's a lot of miscommunication about what even is green chemistry. And many people will kind of assume that it's the same or just a subset of environmental chemistry, which we know is not the case. And so we developed with the ACS GCI, particularly I worked with Jenny McKellar, and we created this oral symposium at the spring national ACS meetings for undergraduate chapters to come and share what it is that they did to make them a green chemistry chapter. So we called that Green Chemistry Student Chapter Stories of Success. And so this is University of Michigan Flint. I don't have too many great pictures, unfortunately, but they were showing us one of the activities that they did. And this was a really fantastic platform where students could come together and tell each other what they did, rather than having to sit and listen to a faculty advisor who may not have done the experiment or done the activity or been at the event, share what their chapter had done, which there's nothing wrong with that from a faculty to faculty perspective, but ACS chapters are so student led that this gave them a chance to do some peer-to-peer conversations and express their frustrations of, why didn't this activity get me the award? Why didn't this count towards it? And then have each other to discuss with. And this also gave us a platform to really clarify what green chemistry is and what it is not. And it was just incredibly fun. So we're hoping to bring that back once we're able to travel and once student chapters are more consistently going back to the ACS meetings. And because of COVID, our outreach has gotten a little bit more creative. So Beyond Benign was invited to participate in the virtual Kids Zone in the fall 2020 meeting, which was fully virtual. And so I was able to represent Beyond Benign and actually showcase one of the activities I had helped to develop as a Beyond Benign staff member, while leading a virtual outreach event we had thousands of viewers, which was shocking. And I think the last count was at about 4,500 people have seen this activity, which is posted on the ACS website. It's on the Beyond Benign website. And just recently, I'll discuss it, but it's become a JChem Ed article with one of our partners. So Really fun activity to be a part of in a virtual sense, where it's so hard to continue doing outreach where you're so used to the hands-on component. And virtual feels really limiting, but in a lot of ways, there's still a lot we can do. And so as I've gotten later in the PhD and as there's been fewer in-person opportunities, some of my focus has shifted to some peer review publications that I've worked with Beyond Benign and other faculty. And so last year we put out, or I guess 2019 now, no sense of time. So we put out this paper in JChem Ed focused on the relationship between chemical safety in green chemistry and informal education settings and K-12 settings. So I was able to share some of my experience with Beyond Benign and doing outreach in that paper with some really fantastic colleagues they're all listed down here, and that's the citation for that. And the outreach activity that I mentioned on the previous slide is actually a focus on edible water capsules. It was inspired by UHO pods out of Skipping Rock's lab in London. They're currently called Not PLA, which you can look up if you're interested, or reach out to me in the chat. I can send you a link. But we were approached by Jane Wissinger from University of Minnesota, who's fantastic and very involved in the green chemistry education space and a part of the Center for Sustainable Polymers at Minnesota. And she had asked if we had anything we could use to work with a student interested in doing an honors thesis related to chemistry education. So that outreach activity that I had started to develop was then taken by an undergrad who developed some really fantastic curriculum and then was piloted in live high school classrooms and is now available to download from the Journal of Chemical Education. So very rewarding. And we have a couple more publications that I've been included on that are coming out in the future related to some invention education work and chem attitudes around green chemistry. So, and then the other one is about teacher trainings and experiences there in New York. So before I wrap up, most of the talk has been about green chemistry outreach, and I would like to just provide some time to show you what I normally would show the students who I'm training in green chemistry outreach. And it's a super simple activity that it's so flexible for whatever age group you want to work with. And it's the E factor activity. So E factor is environmental factor or environmental impact factor. It is the ratio of the mass of waste produced in a chemical reaction over the mass of the desired product that you produce. And the goal here is 0. So it's a pretty fantastical goal, but it is it's a very simple introduction to green chemistry. So the goal is not to promote E factor as the best metric for green chemistry. It is just a way to introduce somebody to the concepts around green chemistry here. Not to say it doesn't have its place in research, but we're talking about outreach. And so it's a really easy way to visualize using colored candies like M&Ms. So we have one fun size pack of M&Ms per student or per participant. And we designate our green M&Ms as our desired product, and every other color is either byproduct or waste. And you tell your students, do not eat your M&Ms. I just want you to sort them. So you have your pile. Now, please sort them into your desired product and your byproducts and your waste. And then you ask them to calculate what their E factor is, which if they can do fractions, they can do that. If not, if you're at a table and you're working with a kindergartner, maybe you just ask which pile is bigger? How much bigger is that pile versus the other pile? So you can really tailor it because it's so visual and it's something that students are familiar with, which is just looking at M&Ms and comparing sizes. And so then you ask them, okay, well, what do we do with all of this waste that we produced? And for some students, you might have to help them there. If they're younger, they might not have worked in a lab. They might not know what we normally do with waste. But you can maybe ask, okay, well, what do we do with like a wrapper from a candy bar? What do we do with our M&M wrapper when we're done eating them? We just throw it out. If they're a high school level or middle school level or higher, you ask them to dispose of their waste because that's normally what we would do in the lab environment. We just dispose of it. So here I have a mason jar. because that's what I had in my apartment when I was making this presentation. But I also really love using either an Erlenmeyer flask or a beaker because it reinforces the kind of chemistry that we're discussing. But M&Ms are great because they dissolve really quickly to form this really brown, sludgy water. And you can it's a good visual that it's waste. It's gone. You're not recovering those M&Ms. You didn't just accidentally put them in the trash and like, you can just pick them out and it didn't touch anything and it's not gross and it's fine. They're not getting those M&Ms back. They're gone. They're waste. And so now they may be sad because their chocolate is gone. It's in the waste. They can't get it back. They might be really, really, really sad because they were really looking forward to eating those M&Ms and now they can't. Or they might be mad at you because you took their chocolate and you told them to get rid of it and now they can't have it. But green chemistry is the science of solutions, not problems. We want to talk about solutions. We want to inspire the next generation to be problem solvers using chemistry. So how do we take all of these sad, negative, angry emotions that we just created by essentially stealing their candy and turn it into something inspirational and memorable that they can take home with them? And so I love to ask, okay, well, what could we do with our byproducts instead? And this is, again, another thing you can tailor to whatever level that you are talking to, whether it's kindergarten and you're just starting to talk about what sustainability is, or just being environmentally conscious, or however it is that you need to phrase that to relate to that student. And you might not have thrown away their M&Ms because you don't want to make a kindergartner cry in front of you. Maybe at this point you could just ask them what they can do to protect the environment, and then they can win back an M&M for every idea, or win back a couple of M&Ms for every idea. And now you're reinforcing that these are good ideas. When we get our byproducts useful, or we can prevent waste, this is a good thing. If you are dealing with middle or high school students or undergrads, I don't usually tell them that I have extra M&Ms because they can sit in the pain a little bit longer. But this is a great time to start thinking creatively about how we can start solving problems rather than just talking about that the problems exist. And so that's really what I want to hit home with today about green chemistry outreach. So green chemistry is a science of solutions. It's not just talking about problems. So for example, there's many people have done the ocean acidification activity in some form, where you use an indicator in a cup of water and you can blow carbon dioxide either from a straw, or you use dry ice to acidify the water and it changes color. That's not green chemistry, that's environmental chemistry. And that is a problem. It's a significant thing that students should be learning about, but that's not green chemistry. What is green chemistry is discussing, okay, well, how can we prevent that from happening by being more creative with the chemistry that we do? Or how can we remediate that using interesting chemical technologies that is trying to solve this problem? So that is it. If you have any questions about green chemistry outreach or anything that I've done in my green chemistry journey, I would love to talk more with you in the breakout session or in the chat, or you can always email me. That's my email up there. It's mollie.enright@rockets.utoledo.edu. And just want to give a shout out to some of my fabulous mentors throughout this green chemistry and professional journey. We have Irv Levy, undergraduate advisor, Jennifer Noseworthy, my undergraduate research advisor. We have Kate Anderson and Amy Cannon, who are both here with us in the chat. And this is my current advisor, Mark Mason. These are the institutions and organizations who I have worked with. And these are also shout outs to the ACS Pharmaceutical Roundtable for funding, and ACS Committee on Community Activities for letting me participate with them in the ACS Kids Zone. I think that's it. So thank you for including me. This was a lot of fun, and I hope that it inspires you to do some green chemistry outreach at your own places. That's it.
Thank you so much, Mollie. That was a really, really engaging and super cool talk. And I love how you included an activity for us to actually see at the end. I think we have time for one question, but before we go into the breakout rooms. But you will get the opportunity to chat with Mollie in the breakout rooms too. Yes, to answer someone in the chat, the slides from today will be made available. Okay, why don't I can see people are still thinking on their questions. So why don't we head out to the breakout rooms, and I'll explain how this round of breakout rooms are going to work. But first, please join me in thanking Mollie for her excellent talk. Perfect. Okay, I'm just going to quickly share my screen then. All right, so this second round of breakout rooms, you will get the choice to join which breakout room you would like to. So Mollie will be in one, and Clara will also be in another one. So you can get the opportunity to chat more about their talks, or you can join a more general breakout room for networking or speaking with some Beyond Benign personnel. So to do this, you should get a pop-up on your screen to prompt you to join a breakout room. If you don't, then you can click breakout rooms at the bottom of your screen and choose which one you would like to join. So we have, I'm gonna say, around 15 minutes in this breakout room discussion. And if Juliana is ready, we can open them now.